I'm Jashwant, and today I'm going to design a MIMO antenna using Altair Feko software. And here the initial step you need to do is you need to go to from home to construct, and here you need to select the model unit. And initially it would be in meters, and you need to make it to convert into millimeters, and then click on OK. And the first step to design MIMO antenna is to take a cuboid. So you will take a cuboid and click on it. And as I have designed my MIMO antenna already, I will show the dimensions alone. So you need to take the first step is to take the cuboid, and here this is the cuboid I have already designed, and these are the dimensions you need to take: width, depth, and height. And click on OK. Now you need to take the feed. So to take the feed, you need to take a rectangle as a click on, you can see here, this is the rectangle part, and click on rectangle and take the feet dimensions in this way. Here we need to take the U 26.5 and width and depth and click on OK. Now you need to take the hexagon. So to take the hexagon, you need to go to the complex surfaces, and here hexagons will be there, and click on it, and here the hexagon, click on that, and here we need to take the dimensions of hexagon here. This is the dimensions of the hexagon part, what you need to take. This is the width, and you need to click on OK. Then you need to click on the both feed and hexagon part. As you can see, control and click on feed 2 and hexagon 1, and you need to make it as a union. Uh, then the next thing you need to do is you need to create the L shape on the hexagon. So for this, you need to take two rectangles with two dimensions, and these are the dimensions you need to take, and then click on OK. And the another rectangle you need to take, and these are the dimensions you need to take for the another rectangle, and click on OK. And right now you need to subtract these two rectangles from that part. So you need to click on control and select these two, and then click on subtract, which is present here, and click on subtract, and you need to select the union part, in which part you need to remove that two rectangles. And then then we need the mirror of the part which is feed and that hexagonal part. So to replicate the same thing which is present here in a opposite direction, so for this you need to click on the subtract part, and select all the things which are present in the subtract part. And right now you need to go to the transform and click on the copy, and here you have the copy and mirror. So click on it, and apply the things which is required for the it should be replicated. So as I have already replicated the thing, you can see here, right now it will generate this type of thing after applying that copy and copy and mirror. Then you need to flip it around like this, and then now here we will create the required ground for this MIMO antenna. So for this also you need to take another rectangle. So as I have already created the ground, so the ground dimensions is this. So you need to take these dimensions and click on OK, and then you need to take another hexagon which is present here. So you will take another hexagon by clicking on this and clicking on hexagons. You need to take another hexagon 1 with the dimensions like this, and then click on OK. And right now you need to remove the so remove the so right now you need to remove that hexagonal part here. So you will click on the ground and hexagon, and you will click on the subtract part, and you will remove that thing, and you will generate the thing in this way. And right now we need to create the ports for this thing. So for creating the ports, we need to, here we will take the ports, and here another two ports we will take. So to create the ports, we need to take two another rectangles which should be presented here. So we need to take two rectangles. Yeah, this is the rectangle one dimensions and the arrangement of it. And then for the rectangle two, we need to click on it. And this is the rectangle two arrangement for this and the dimensions required for this. And then this is hexagon two is another hexagon which is present between that ground and the hexagon here, and you need to take this. And now we will apply the ports. So before applying the ports, so you need to union every part which is present here. So to union every part, you need to click on control and select everything which is present here. Yeah, after clicking everything, you need to click on the union, and then uh, now we will apply the ports. Here you need to apply the one port, and here you need to apply the another port. So for applying ports, you need to go to the source or load, and here you need to take the waveguide port for MIMO antenna, and click on the waveguide port, and click here at what phase you need to apply the waveguide port, and click on that particular phase, and then it will select the particular phase. And here we need to orient the 90 degrees, 180 degrees like this, and here we need to select the 90 degrees orientation and click on create. And then you need to take another waveguide port, and right now you click on the another phase and click on 90 degrees and create. So here now we need to take the sources on the ports. So here this is the waveguide source is there. So click on waveguide source, and here we need to select it waveguide port 1 and create. And then you need to take another source. So right now you need to take waveguide port 2 and again create. So after this part you need to click on the mesh, and you need to apply the automatic mesh here. It will apply the automatic mesh, and as you can uh, here you can see the mesh which is aligned with the MIMO antenna. And now our design is completed. So right now we need to go to the solver run. No, we need to go to the request phase, and here we need to select the frequency range. So for this you can go to configurations also and click on the frequency part. Yeah, here we need to select the different things, and here I selected linear space discrete points and click on it. And here I choose the start frequency as 0.5 gigahertz and end frequency as 15 gigahertz. And here number of frequencies I took as 150. And then you need to click on OK. And now we need to go to the solver, and now we will do the FICO solver. As I have already completed my FICO solving property. So for FICO solving property, it will take around 1 hour. Why? Because we take 0.5 gigahertz to 15 gigahertz, and we take 150 points. So it will take more time. So right now I will go to the post FICO. Click on post FICO. Yeah, click on post FICO. After clicking on post Feko, you will get the complete design with as I took far field and it's showing far field, uh, and this is a this is gain at different frequencies. I will show, and this is at another particular frequency of gain, and then this is at another particular frequency. As here you can see, this is at 8 gigahertz, and this is at 5 gigahertz frequency, and again this is at 0.5 gigahertz. So this is the gain which is changing as a frequency goes on increases, and this is the far field diagram what I took, and for different frequencies 0.5 gigahertz and 5.1 gigahertz and 8 gigahertz and 10 gigahertz. This is the far field polar graph which is changing according to the frequency. Mm. And then yeah, this is the reflection coefficient for the for our uh, for our MIMO antenna which is designed. So for the MIMO antenna it should be less than minus 10 dB. So you can see at at 4 gigahertz and at 8 gigahertz it is less than minus 10 dB, and as it is at 13 gigahertz it is greater, it is about 10 dB. So we need to do some changes to make it again less than minus 10 dB. So this is my design. Thank you to all.